70-464 Virtual Nugget Lab Solution Nugget. In this nugget, we are going to walk through the lab manual task by task. We'll answer the challenge questions, we'll do the challenge tasks, and we'll have a good time. Let's do it. Let's start by going over the virtual lab manual. So here it is, the lab manual for the 70-464 Virtual Lab. Our learning goals here were to first work with data and referential integrity. On the data integrity side, working with things like primary key, default, and null constraints, popular ways to enforce data integrity. On the referential integrity side, just getting familiar with how to use transact SQL to create your relationships and how to deal with things like many-to-many relationships. Another learning goal here is using views to create a data access layer. A popular objective inside of 464, there's a couple that have to deal with views and their design, using them as a data access layer and using them as a way to simplify permissions through ownership chaining, something we covered in the course. Next up, rewrite a poorly written query. We'll see how to take a query that contains subqueries and write it to something that's a little more optimal, such as a derived table or a join. We'll also look at how to create stored procedures with optional parameters. This is a good one for a number of reasons, but in the real world, rather than have 100 stored procedures, why not consolidate them into a few dynamic stored procedures with optional parameters that callers can call many different ways. So stored procedures along with views are really all we should need for our data access layer. And that's one of the task questions, the challenge questions we'll ask is, when would you use a stored procedure or over a view or vice versa? That's a great question. So we'll answer that one. Also, design and create an indexing strategy. There were 3 objectives in 464 that dealt with indexing. So it's a very good idea to know your indexes in and out. And we'll see how to create an indexing strategy and then make sure we utilize those indexes using the stored procedure and views we created in previous tasks. And obviously, coming up with an indexing strategy is one thing, but we need to keep these indexes in tip-top shape. So the idea here is to get you familiar with how to come up with an index maintenance strategy and automate it using SQL Server Agent. Another popular question that I ask here that I see all over in practice exams is what's the difference between rebuilding and reorganizing, and when should you rebuild over reorganize an index? So we'll answer that one. Also use Extended Events Profiler to monitor activity. Extended events are the future of monitoring in SQL Server. Eventually, SQL Profiler will sadly go away, but hopefully we'll be able to do it all in extended events. So the idea here was to get you familiar with how to capture stored procedure executions and also capture execution plans. That's a really good one to know how to do, because if you have something that's hitting your system, you want to be able to identify it and then troubleshoot and tune it so we can get it in optimal shape. And finally, the last learning goal is to get you familiar with how to create a partition table, a partition index, and a partition view. The distributed partition view here is actually the final challenge task of the virtual lab. It's a good one, so we'll check that out when we get there. Now, the scenario here is that you've been asked to design, implement, and maintain the data storage and access layers. You will be responsible for creating and providing access to the schema that stores trainer, course, video, and learner information. As far as the environment goes, we have a default instance of SQL Server 2012 Developer Edition set up on the server. So that's why you'll connect to the default instance, which will assume the name of the server, SQL Nugget Lab. The database we'll be working with here is Nugget Lab DB. There are some instructions and related documentation for books online in case you get stuck. But let's get to it here. We're going to start by heading over to the virtual Nugget Lab and getting familiar with the environment. And then we'll come back and we'll walk through each task individually. So here is the virtual Nugget Lab. And this is what you'll see as soon as you launch the virtual lab through the Nuggets website. First, let me just take you into the Nugget Lab files. This is a shortcut on the desktop that takes you into this, just in the C drive, Nugget Lab files directory. We're going to be honed in on 70-464. Inside of Lab 1 contains many of the scripts that we'll be working with in the lab. And note that I did add a solution folder with a script in here that contains a solution for each task. So don't cheat. Try to do it yourself before you look at all the solutions. All right, so let's start here by firing up Management Studio. We'll get a connection here to SQL Nugget Lab, our default SQL Server instance. Expand databases over here in Object Explorer. Expand our Nugget Lab DB, and you can see that this is empty. This is empty, and the first task, if we flip over to the lab manual, is going to have us fire up this script, NLDB schema, analyze the transact SQL to get familiar with all the tables, and then execute it to create them and load them with sample data. So let's open up that NLDB schema.SQL script here using Management Studio and take a peek at what it looks like. And let me just get rid of Solution Explorer over here so we have more real estate to work with. And this is the same schema we worked with in the 464 course, just a little more simplified so we could really just focus on working with these objects themselves. So category table here contains all the categories. Course category is what links courses to categories. That way we can represent a many-to-many relationship. Courses can contain many categories. We also have a nugget table that's tied to courses. Courses contain nuggets. And then we have a trainer table. Courses are associated with trainers. So the idea for this task was just to have you get familiar with it. Look at it and then execute it, which will create those tables and load them up with sample data. And if we refresh over here in Object Explorer, we can see all those tables, and there we go. All the data made it in. So that was task number 1. Task number 2 is to review these tables for any data integrity issues and add primary key, null, and default constraints where missing or where you see appropriate, and then add referential integrity by creating the relationships. So if you'll notice, I didn't create any relationships whatsoever. Really just created the tables and loaded them with data. So there's no referential integrity, and we're missing data integrity. I don't know if you've pinpointed them. Could you see any here? We've got one on the name. We're also missing a primary key down here on the nugget table, and then we have no defaults. So the idea here was to just have you look at these, identify where we could add both data integrity constraints and then also referential integrity. So how did you do with this one? Did you notice here in the category table that name didn't have a nullability option specified, which means it will default to null? And obviously the name describes the category, so that's pretty important. So this would be one that we would want to say not null. And since we already created a table, you could either write an alter and then alter column and do it not null, or we could just go in the designer here and flip it. Actually, let me open up the solution here. Oop, that's not the solution, because I did add the alter table statements inside of here. So here we go. Here's task 2. Here's a solution, not null on category. So we could do an alter table category, alter column name, and then set it to not null. So if we look at category right now, we can see that name is null. Let's execute this and then refresh our columns, and now it's not null. The next one here is our nugget table. It was missing a primary key, and if we expand the nugget table, we can see that it's missing primary key. Also notice in the key node down here, there's nothing. So the idea here would be to add one using T-SQL. We can just do an alter table nugget, add constraint, name of the constraint, primary key as a clustered index on nugget ID. So let's execute this. That will create it. Now if we refresh, we have a primary key. If we refresh this, we have yet another primary key. So excellent. We have a primary key on the nugget table. That was the other one. And the last one here is defaults. Identify defaults. Could you identify any defaults? This is kind of a tough one to see, but looking at the nugget table here, we could probably get a default on, say, duration. Set it to 0. That's probably a good idea. That way, programmers won't have to code around nulls, or us when we're creating stored procedures won't have to trap for that every time and change it. Another one here is final. Bit fields are always good to specify a default on, so we'll specify 0 as a default. So let's just add these defaults here, and that should do it. And now we can see this in the constraints folder. Here are both of our defaults. The second part of this task is configuring relationships between these tables by enforcing foreign key constraints. And if we head back to the lab manual, we had 4 of them. We had nugget to course on course ID. That way we could tell what nuggets belong to what course. So our foreign key inside of our nugget table will be course ID. Course to trainer on trainer ID. That way we can identify what trainer taught a course or belongs to a course. And then we have a many-to-many relationship here. We have this intermediate table called course category, which allows us to associate courses with multiple categories and categories with multiple courses. So we're going to set up a relationship between category ID and course to course category and category to course category. Let's head back to the virtual Nugget lab for this one. And I did just add one fun one in here, the first one. This actually isn't in the lab manual, in the solution here. But our category table, and we did this in the 464 course, has a parent category ID. And this way, you could have categories have parent categories and create this hierarchy, which is good for testing out things like recursive CTE. So we have a self-referencing relationship going on here. So I just added that one in there for fun. But the ones in the lab manual here is our trainer ID foreign key between our course table and our trainer table. So there you go. There's a trainer ID there. And if we look at this, course has trainer ID in it, and then our trainer table, of course, lists all of our trainer and has a trainer ID. So this will set up the foreign key inside of our course table that references the primary key inside of our trainer table. And then on our nugget table, we're doing the same thing between course IDs, course category, between category ID and then course category between course IDs. So you can see the syntax here is actually pretty straightforward once you get the hang of it. It's just all about specifying the foreign key in the table that you're altering and what it references table field name. So let's highlight all these and hit execute. And now if we head over here to our course table and let's just refresh, we should see this trainer ID turn into a key, so we can get visual notification here that we have a foreign key in this table referencing the primary key in our trainer ID and our trainer table. And also if we expand keys here and refresh, we should see it as our foreign key in here. Excellent. So that was task number 2, data integrity and referential integrity. Let's answer some challenge questions. So the first one here, what are the cascading referential integrity options and what do they do? First of all, cascading is what happens to child records when something happens to the parent records. And I think this is best seen with the visual. So let's say we have our course table here, and we have a Nugget table here. We have a course ID as the primary key in our course table, and then we have the course ID as the foreign key here in our Nugget table. So we have a course, and we have many Nuggets. So what happens if we were to delete a course? Well, if we have cascading turned on, depending on our option, it will remove all the associated Nuggets with it. Now, by default, that doesn't happen. The default is no action. No action is the most restrictive. It means if we try to delete this record, and it has referenced records inside of a child table here in a foreign key, then it's going to cause an error. So that's the most restrictive, that's the default, and that's what would happen right now in our table. We didn't specify any cascading options, so if we deleted a course, it had Nuggets, the user would get an error. And that's good, right? That's by design. Now, if you did want cascading to occur, though, there's a couple of options. There is the cascade options, which means if we were to delete this, all these Nuggets would be gone as well. There's also the set null option. Set null means if we were to delete this, then rather than delete these Nuggets, because they may be tied to reports or anything else out there, then just set their course ID to null. So we don't really touch the record other than the course ID. We just disassociate it with that course that got deleted. And then the last one is set default. Set default just means that if we have a default on this record, then it will set it to its default value, or we could provide a default that it would then set it to. So those are your cascading referential integrity options. How about this next question? How would you implement a many-to-many relationship between trainers and courses? So right now we have a trainer table that contains a trainer ID as our primary key. We also have a courses table which contains a trainer ID as its foreign key. So right now we can have a trainer associated with many courses, but we cannot have a course associated with many trainers. What if we created a course that had multiple trainers on it? Like we do. We have Cisco courses that have both Keith Barker and Anthony Sequeira on them. So this would be a good example of how to implement that. And what we would do is create an intermediate table, one in between, called trainers to courses that would contain the trainer ID and the course ID. Then these would just link on their primary keys to this table, and that would allow us to do a many-to-many relationship. All right, let's move on to task number 3. Create a view named NLVW_courses that returns the following results. Use subqueries for these last 2 columns here, total Nuggets and total duration. So we're going to need to write a subquery to head over to the Nuggets table to aggregate these values and return them. So we're going to create a view to do this. Let's head over here to the virtual Nugget Lab and scroll down to task number 3. So here's what I came up with for NLVW_courses view. It's going to grab title, description, trainer, just like we had in the lab manual here, title, description, trainer. And then for the last 2, we need to head over to the Nugget table to grab counts. So we're going to grab a count of total Nuggets, and then we're going to sum up total duration and also format it nice and pretty so it looks like so in the form of hours and minutes. And I didn't add that in here as a requirement, so don't worry about it, even though I said return it here. But if you did watch the 464 course, we did that many times. So you probably could dig up that code if you needed to. But here it is. Here's our view. Not too bad, right? It looks pretty straightforward. So let's execute it. And then let's write a select statement against it here. Select star from NLVW_courses. And we should get the same results that we see inside of the lab manual. Excellent. Let's answer some challenge questions here. What are the benefits of using views as part of your data access layer? The answer to that is really a couple of reasons. The first one is permission management due to what's known as ownership chaining. We'll answer that one next. but also it simplifies our schema for anybody using our database. Because a lot of the times you're going to have this big complex database with lots of tables and lots of fields and lots of joins. And for those report writers and business analysts and programmers out there, we want to give them a nice simple view of the database to work with. So that's where views really come into play. The second part of this question, what is ownership chaining and how does it simplify permission management? This is also best seen with a visual here, so let me bust out the pen. So let's say that we're right here. This will be we, or us, or we're one person right now. I'm getting all existential on you. So this is us, all right, and we create this view. Now, inside of this view, let's say that we reference another view, and that view references multiple tables. So you see what this is here? This is a chain. This is where the chaining part of ownership chaining comes into play. Now, here's the idea. We're the owner of this view, right? And if, say, Bob, who doesn't have access to these underlying objects, wants to use our view, we can just simply give Bob access to the view. You will not need access to the underlying tables. That's where the ownership chaining part comes into play, because if we did give Bob access to this view and he executed it, permissions are only checked on the first object. They would be skipped on all of these objects. So that's how it simplifies permission management. We wouldn't have to get very, down and detailed with our permissions on every single object within this view. And you also get a performance boost, by the way, just a minimal one, because permissions are completely ignored on these underlying objects. So there's our questions. We've also got a couple of challenge tasks associated with this one. The first one is alter and rewrite the view using derived tables rather than subqueries for the outer table aggregations. Notice that I had you write subqueries to get your outer table aggregations there. Well, as we know, subqueries are bad for performance. So the idea here was to get you thinking of how to rewrite this using derived tables. Let's head over to the Virtual Nugget Lab and scroll down. Here is the solution. So you'll notice these two subqueries I rolled into one derived table. Think of a derived table as a subquery in your from clause. The big bonus here is that we took two queries and turned it into one. Also, since it's in the from clause, we can join to it, which is much more efficient. We can take better advantage of our indexes and such. But the results are going to be the exact same. In fact, let's just alter this view, rewrite it, and also notice that it looks a lot cleaner, doesn't it? It's nice to have nice, clean select clauses rather than cluttered up with lots of this kind of stuff here as subqueries. All right, so let's execute it. We'll create it. We'll re-execute our select query here, and look at that. The same exact results. The only thing I didn't do there was format it nice and neat. So we could do this right here to format it nice and neat if we wanted to, and wrap that around our total duration there. Heading back to the lab manual, we have one more challenge task here. Create another view named NLVW Nuggets that returns information about videos and the courses they belong to. This is just kind of a free-form task. Hope you had fun with it to create your own view, bring back whatever information you want. To show you what I came up with here, I just came up with a very simple view that joined together those three tables, brought back all the Nugget information, the course associated with it, and also the trainer associated with that course. So again, there's no right or wrong answer here. Just wanted you to have a little fun with creating your own view. And there's the results of mine. Looks like so. Excellent. Moving on to task number 4. This is a fun one. Create a stored procedure named NLSP Get Courses that acts as a search engine and returns course name, course description, and trainer name. Here you're going to use optional parameters to create a dynamic predicate and then write many execute statements to call the stored procedures in different ways. So here's the procedure, NLSP Get Courses. Here's the parameters I wanted you to use. Course ID, course title, course description, category name, and trainer name. So we should be able to use this stored procedure to pass in a mix of any of these, or none of them, to get all the courses. So that's the idea here with the stored procedure that has a dynamic predicate that uses optional parameters. How did you do it? Let's head over to the Virtual Nugget Lab. Scroll down here to our procedure. So here it is. Here is, again, our parameters, and here is the bulk of it. So we're returning course name, course description, trainer name. We're joining all the tables together that we need. And then here's the magic here. And what you're going to want to do when you deal with optional parameters is do it like this. Because doing it like this, using a Boolean statement that checks the nullability of the parameter, meaning if it's null, it's going to completely ignore this line. The query optimizer will completely ignore it. So the only downside to this is that execution plans, you need to be careful here with execution plans because you want them to get recompiled upon every use. If not, it may use an execution plan that was for a completely different predicate, which would be bad. And this is why we add the option recompile on it here so we can get a brand new query plan every single time. But the idea here then is that we can execute this, and by the way, we need to create this first, so let's just do that. Create the stored procedure, and now we can execute it a variety of ways. We can execute it with no parameters to get every single course. We can execute it with a course ID to get just that course. We can execute it using a name, or a, which one was this one? Description, title to get anything with that in the course title here. We could do it with, just to skip down a little bit here, by category. So if we wanted to get all the courses that had the Cisco category, here they are, filled with Chara and Barker and Shannon and Sequeira. And then we can also here do it just by trainer. There it is. There's all the stuff I've done. And then we can also do it by category and trainer. So if we want to see all of the courses that are in the Cisco category that were done by Keith Barker, we can hit execute. And there they are. Pretty cool stuff, huh? So that is how you can create a dynamic stored procedure using optional parameters. Let's go answer some questions. The first set of questions here, what are query hints? Well, I'll answer that one right now. A query hint is a way for us to really set an option on the query during runtime. There are also join hints and table hints, so they allow us to change the behavior of the query while it's executing. And what hint would you use to ensure the execution plan for a query with the dynamic predicate is recompiled each execution? We just saw that one option, recompile. And we would want to do this so we get a fresh execution plan every time we executed a stored procedure like that. Because again, if we reused a different plan, then we could really be hurting performance there. And then another good question here, when would you use a stored procedure over a view? Generally, you're going to use stored procedures when you need to run some kind of business rule, enforce some logic, or validate some kind of data coming in. So stored procedures are great when you're catching data to put into the database. There's a front line of defense against that data coming in because we can write code to analyze it and validate it and run rules and do all that kind of stuff. Or doing stuff like this when you're creating a search engine on top of your data. Views are good for everything else. Let's move on to task number 5, which is coming up with an indexing strategy for the Nugget Lab DB tables and then using our views and stored procedures to ensure that they are being used. So let's head back to the virtual Nugget Lab. Now, it's tricky when you're designing a database to come up with an indexing strategy because you don't know what queries are hitting your database, how they're hitting your database, where the hotspots are and such. So when you're designing, it's trickier, but you can usually tell by looking at your tables what are going to be the popular things people are going to query on. So for instance, let's take our course table here. Well, first we can employ good indexing strategies, and that is always index your foreign keys. So that's the first one I have on our course table is an index on our trainer ID. And if people were to join to this table, the data they would most likely pull out are going to be title, description, and completion date. Now, this is an easy one, obviously, because we don't have many fields, so we can just include all of them. And this index should cover most of our needs for our course table. And then also, we should put a separate index on the title, because if people do search against this table, they're going to be searching courses probably by title and description. So that's why we added title in here as its own index, non-clustered index, and then included description and completion date. Now let's scroll down and look at our Nugget table here, see what we can come up with. Oh, that's not our Nugget table, that one is. And we can see here, now we have a little more fields to work with, but right off the bat here, we could probably use our foreign key, course ID, so that's what we're doing right off the bat, employing good indexing strategies, indexing our foreign key. And we're saying if people do join to this table, what data will they most likely pull out? Probably name of the nugget, description, sequence, and duration. Now we have one more index on our Nugget table, and this one is for those searches that come directly against this table. If someone were to search for nuggets, they'd probably search by name, so that's why it'd be a good idea to create an index with name as the key, and then we also include description, sequence, and duration. That way anybody that pulls these out would probably also pull out those fields. And including is very good, because if you include fields and then a query comes in that requests all the included fields, that means the query optimizer can satisfy the query purely by the index without having to do any extra work or going to the data pages to retrieve the data. So we can get huge performance gains when that is the case. And we've got a couple of simple non-clustered indexes here on the category table, just on name. That's a pretty obvious one. It's the only column really in there anyway. And then on the trainer table, we're going to index on first name and last name, because searches would probably come in against the first and last name, and we've been pulling it out a lot in all of our queries, so that'll be a good one to put an index on. So let's highlight all of these indexes and create them. There we go. Now, how can we see if these indexes are being hit? Well, first thing we want to do is turn on include actual execution plan. So any queries that we execute or stored procedures that we execute, we'll be able to see the execution plan, to see the exact route that it took. Now, the next thing here is to pick a query. Let's pick this one right here. And if we look at this execution, we're going to search here by category and trainer. So if we look at our indexes that we created here, we should be hitting our category name because we're searching by category here, and we should hit our trainer index that's indexed on first and last name. So if we hit execute and we look at the execution plan, is it what we're going to get? Let's scroll over. There is one. This is using our index category name, so that's one. That's good. Then we've got a couple of clustered index scans and seeks here. Those are from our joins. And then our last one here is also going to be against trainer first and last name. So that's exactly what we would expect because we executed the stored procedure, which is going to use that dynamic predicate to search by category name and trainer name. And those are both of the indexes that we hit. So very good. Let's head back to the lab manual and answer some questions here. So how do you determine what indexes to create? How can you identify missing or unused indexes? Well, the first question here, usually you're going to determine what indexes to create by the activity that is hitting your database. So you want to get a good understanding of the queries that are hitting your database and then always index foreign keys and then index your predicates. That's a great indexing strategy to employ. How can you identify missing or unused indexes? Well, one is the execution plan will show us missing indexes. Anytime you execute a query and you look at the execution plan, if it didn't use an index, it will usually suggest one. And you can find unused indexes by using the index usage dynamic management view. The next question, what tools can you use to design an indexing strategy based on workloads hitting the database or scripts containing queries? Well, the main tool that I was looking for here is the Database Engine Tuning Advisor. We can toss it a workload you can create by using SQL Profiler, so you can trap for events, trap for queries that hit the database throughout the day, take the results, send it in the Database Engine Tuning Advisor, and it will give us recommendations for things like indexes. Also, if you just have a script containing a query or a bunch of queries, you can also feed that to the Tuning Advisor, and it will, again, give us an idea of what we should be doing to optimize and tune our databases. And finally here, name the index types available in SQL Server 2012. Again, it's good to know you're indexing in and out. We have the clustered index, one per table. That is always a good idea to have a clustered index per table, except on those really small tables. We have the non-clustered index. We can have many of those per table. That's going to be our main driver of performance for searches against our tables. And within non-clustered indexes, you can have included indexes, which we saw here is a great way to include the data in the index, so it'll be a lot less work for the optimizer to do. If a query comes in that only needs all the fields out of the index, it can pull it out of the index. Also, filtered indexes are very good because we can make an index that only works with a small subset of data, so we have a really small streamlined index to work with. And then we also have the column store index, which is a new index in 2012 here that is optimized for data warehousing. You can only have one per database. Generally, you're going to create one index that has all the columns in the table, and it'll really speed up queries against those tables. So those are your indexing types. Let's move on to task number 6. Create a maintenance strategy using T-SQL to reorganize indexes and update statistics for the indexes on the category and trainer tables, and then rebuild indexes on the course and Nugget tables. Then create a SQL Server agent job to automate the maintenance strategy and execute the job every night at 1 a.m. Then we're going to want to test it by manually executing the job and then view index fragmentation using a DMV to ensure it's successful and to ensure that our fragmentation went back down to 0. Let's head over to the virtual Nugget lab, scroll down here to task number 6, and what I wanted you to do here is just rebuild on the course and Nugget table, so that's easy. To rebuild all the indexes on a table, just do an alter index all on table name, rebuild. So rebuilding will completely rebuild, drop and recreate the index. And also, by the way, if you didn't want to rebuild all indexes here, you could specify the name of the index. So let's rebuild our indexes on course and our Nugget table. Easy enough, right? And then on our category and trainer tables, we're going to reorganize, which does not rebuild. And anytime you reorganize an index, you'll also want to update the statistics. So same syntax here, just with the reorganize over rebuild. And then we're going to update the statistics on both of those tables. All right, let's do it. There we go. That's easy enough. And then here's what we're going to do here is view the index fragmentation, and then I'll show you how we can automate that strategy. So here is a DMV, DMDB index physical stats. If you join this with objects and indexes, you can get some good information out of these indexes. But if we execute this now, here are all the indexes on our Nugget Lab DB in our Nugget Lab DB database. And if we scroll over here, our fragmentation should be next to nothing for most of these, which it is, and that's very good. So obviously we need an index strategy. There it is. Let's highlight all of these, copy it. I'm just going to go do this manually in SQL Server Agent just to show you how to create a job here. We can right click on jobs, hit new job, give it a name. We'll call this our maintenance strat. Head over to steps. We'll create a new step. The first one here, let's just call this one rebuild. Rebuild is going to be transact SQL. It's going to be against our Nugget Lab DB. We'll paste this in, and I'm going to take our reorganize and cut it out of here. So we just have our rebuild in this step. Looks good. And then we'll add one more step. We'll call this one reorg. Same thing, Nugget Lab DB. We'll paste it in, and we look good. We'll hit OK, and now we can set up a schedule. So we'll specify a schedule here. We'll call this daily 1 a.m. We'll set it up for daily. It'll occur at 1 a.m. every evening. There it is. That's it. That's all there is to it. Job created. And now we can test it by right-clicking on it and starting the job. You can start it at a specific step here. We want to start it at step 1. That'll create it. It's running through. It's rebuilding the indexes, reorganizing the indexes, updating statistics, and it's done. Let's head back to the lab manual and answer some questions. So what is the difference between reorganizing and rebuilding? When should you reorganize? And when should you rebuild? So again, reorganizing just reorganizes all of the leaf level pages of the index. It doesn't update statistics, and that's why a lot of the times people prefer to rebuild an index, because it's just like dropping it and recreating it. But that can be tough to do on an extremely large table and take a very long time. So that's why a good strategy here when it comes to reorganizing versus rebuilding is if it's greater than 5% and less than 30%, reorganizing is fine. If it's greater than 30%, rebuild, and if it's less than 5%, leave it alone. Those are just some great general rules to live by when it comes to index maintenance. The second question here, what other tools can you use to build a maintenance strategy? And this is a good one because there's a lot of great tools out there. One, we have maintenance plans built into SQL Server. They're very simple to use and set up. It's like a lightweight version of SSIS built right in. You have a designer, but it's restrictive to what you can do. You're not going to be able to get very flexible. So they're good for quick and dirty maintenance plans. You could also bust out SSIS. If you want to create your own maintenance plan, you get all the flexibility there. The downside, obviously, is you need to understand SSIS, which is actually really easy and fun to learn. So if you don't know it, pick it up. It's a great skill to have and a great tool all around. And then another way to do it, the preferred method out there in the real world, and my really preferred method, is using Ola Hallengren's script, which is really easy and awesome and takes into account the rules that we were just talking about here with reorganizing versus rebuilding. So check that out. We covered it in the 464 course. Let's move on to task number 7 here. Create an extended event session named NLXE_Sprox to capture stored procedure statement executions against the Nugget Lab DB database. And then we're going to start the session, launch the live monitor, execute the stored procedure, and watch it happen live in our database. So let's head back to the virtual Nugget Lab, where we will expand our management node, expand extended events. We'll right-click on sessions. We're going to create a new session here using the wizard. We'll choose next. Let's give this the name here. We wanted you to call this NLXE_Sprox. Right? Is that what I said? NLXE_Sprox. Perfect. Hey, I got it. And then we'll choose next in the wizard. Template here, we're not going to use a template. We're going to create our own. And if we want to do Sprox executions, we can just start typing in SP. And if you scroll down here, SP statement completed. Anytime a statement inside of stored procedure completed, this will happen. You can also do statement starting. But let's stick with completed. And let's also do plan cache here. In fact, here, if we type in plan up here in the little search, we should get query post execution show plan. So when a query is done executing, its show plan will be stored so we can actually capture execution plans. So let's just throw that one in there for fun too. Then we can choose next. Here we can get some global fields to capture. If we wanted to throw anything else inside of the event data, then we could all check it all here. We can also put filters on. So if we wanted to filter out the database, we could do that. Let's just keep this one simple for now, and I'll show you how we can edit it. We'll hit finish. That will create it. Now we can expand sessions, right-click and start our extended event session. We can also then right-click and choose watch live data. That will launch the monitor. Now while that's launching, let's head back here and execute one of our stored procedures. How about this one once again? We'll execute it. Now we can head back here And as soon as it's done retrieving, we should, check it out, there is our object name. And if we scroll back here, here is the actual procedure that was executed. If you scroll down, here is the statement. So you can double click on it, and there it is. There's our statement that was captured. And again, here is our execution plan. And the beauty of this is we got a query plan tab right here, so you can actually see the execution plan. Look familiar? There is our category name index that was used and our trainer index that was used. So these are great. And again, if you do want to put filters in, you can always go in after the fact, head into properties, head into your events, and over here on the configure tab, you can add predicates in here. So if we wanted to, and you have to stop it in order to do this, but if you did want to do this, you'll just drop this down, choose database name, put in the value of your database name, and then you'll only be capturing things against your database rather than the entire server. Let's head back to the lab manual and answer the question here. What other methods can you use to capture and monitor instance and database activity? Well, we have the activity monitor, which is the live monitor at the instance level built right into SQL Server. We also have SQL Profiler, which is good, but sadly it is getting deprecated, as I mentioned. And then we also have Performance Monitor, which is a Windows tool that we can use to monitor performance, and various SQL Server counters are out there to help us out. You can also use DMVs, lots of DMVs to analyze the current state of SQL Server and the health as well. Let's move on to task number 8, where we are going to create a partition table. We have a lot of steps here to guide you through. Let's head over to the virtual Nugget Lab and make this happen. So the first thing we need to do is add some file groups here to the database. And you can do this if you wanted to just go into database properties, and then you can add a couple of new file groups here, and then you can add new files here into those file groups. We're going to do this in Transact SQL though. So the first thing we're going to do is create those two file groups, NDDB1 and NDDB2. All right, there we go. Then we're going to create two files and add them into those file groups. So there's one, there's two. Let's do that. And if we look on disk here, we should be able to see them. There they are, NDDB1, NDDB2. And then if we head down here, we need to create a partition function. This is what is going to determine how the data is broken up. So we're going to do a range right here, which is essentially we're saying anything prior to this date will go into NDDB1, anything after this date will go into NDDB2. So that's called a partition function. Then we're going to create a partition scheme that actually separates that out. Anything less than 1/1/2008, NDDB1. Anything greater than 2008, NDDB2. So this is just essentially going to map. Your function is going to map to your scheme. This is going to map to this, and then anything after that, since we did a range right, is going to map to this. If we did a range left, it would just be the reverse. Anything before this will go to NDDB1. Anything from here after them would go to NDDB2. So let's create both of these. Partition function, partition scheme. And then the next step here was to create this table. Now, let me just head back to the manual for a second. We just did the first 4 steps. The 5th step here, I'm going to have you open and analyze the script and then modify the create table statement to use the partition scheme above and specify creation date as the partition column. So let's head back here, and what I wanted you to do is open up this script called learner schema. So if you open this up, this is what it looks like. Everything's done on primary. So your job was to modify this so it was created on that partition scheme, which would make it a partition table. And here's what the result would look like then. The only difference between that one and this one is instead of on primary, we do on, here's our partition scheme, and then specify our partition column being the creation date. That's the date that will get filtered through the scheme in the function, and the data then will go into the appropriate file on disk. So let's create this learner table, and now load it with data. And that was the last step here in this task, is open the script, learner load.sql, and execute it. And then view the files on disk and write a query against sys.partitions to make sure that the data was loaded. So here is that script. Here's the data. Just a bunch of insert statements here that span many years. We're going to have a couple before 2008 and quite a few after 2008. So if we insert into that learner partition table all of these rows, all that data should get split up. And now we can write a simple query against sys.partitions where the table name is learner here. That's why we join it to sys.table. So we can just look at the partitions here for this learner table. We should have 2 of them. We do. Here's partition number 1, NDDB1. Here's partition number 2, NDDB2. And here are the rows, 5 and 5. So we did get an even split there. But that's it. That's pretty easy, right? Partition tables aren't too bad. It's just really getting familiar with the process. And if we head back to the lab manual here, the question is, what are the benefits of partition tables? Well, while you can get a performance benefit, especially if you do put those files on separate disks, mainly partition tables are used for management of extremely large tables. It makes it a lot easier to manage the data. You can do partition switching. We need to remove old data rather than run delete statements, which would take years in some cases when you're dealing with that volume of data. So those are going to be the big benefits, mainly for management purposes, but a nice little side effect there is you can get a performance boost as well. Let's move on to task number 9 here, which is to create a filtered index on top of that partition learner table with first and last name as the index key, include address as subscriber and creation date, use where is subscriber equals 1 as the filter predicate, and write a query that targets the index. All right, so let's do this. Let's head over to the Nugget Lab again here. And task number 9, we are going to create that filtered index on learner, first name, last name. We're going to include address as subscriber and creation date, where is subscriber equals 1. Now, before we do this, let's just run this query by setting statistics.io on and then turning it off. So we're going to document what our current performance metrics are like. We'll create the filtered index, run it again, and compare the metrics. So if we head over to message here, we can see we've got a scan count of 2, a logical reads of 6. So we should be able to cut that down. Even though we're dealing with an incredibly small amount of data, this is a good way to even test performance at this minuscule level. So let's go ahead and execute that to create our index, our non-clustered included filtered index. And now let's rerun that query with statistics on. Look at messages, and look at that. We cut it down from 6 to 4. So there you go. And looking at the lab manual here, the whole reason I had you do that is because we created what's called a partition index, because we created an index on top of a partition table. And by doing that, it automatically partitioned the index using that same partition scheme. And yes, that is known as an align index. You can create what are called unaligned indexes, which is creating an index on its own file group that is non-partitioned. It would be known as an unaligned index. And there are pros and cons to both of those strategies. All right, we made it to the final challenge task. So this last challenge task is all about creating a partitioned view. So we're going to analyze and execute the following script, the final challenge schema, which is going to create member tables, learner 2010, 2011, and 2012. Then your job is to create a partition view on top of these tables that brings all the data together, and then load the tables using the partition view. The cool thing is here is once we get the table set up, we create a view, then we can start sending data through the view, and SQL will take care of putting that data in the right table. Another benefit here of this is anytime we write a query, the query optimizer will only pull data if the query only targets, say, a specific year. Say we write a query that targets only data in 2012, it will only pull the data out of that one table, so we can get some good performance gains out of this as well. So let's do this. Let's start by heading into the virtual Nugget Lab. Let's go ahead and load up the first one, which is the final challenge schema.sql. We're going to execute this, which is going to create our member tables. It's going to create our member tables, and the whole magic behind partitioned views is right here, putting a check constraint on the column that is going to be what's known as our partitioning column, and then also ensuring that that is part of your primary key. That's the magic. So as long as you follow those rules, you'll be in good shape with creating partition views or even distributed partition views. So let's do this. That's going to create the schema, and if we look at our Nugget Lab DB here, let's just refresh our tables. There are those 3 member tables. Let's head back to solutions now. Your job was to create the partition view, which is actually very easy to do. It's just a view that unions all those tables together. Simple, right? There it is. Now, these tables are all empty because if we scroll down, I have some select statements. If we just run these select statements, you can see they're empty. Even if we run the select statement against our view, same results, all empty. So what we can do now, and what you were supposed to do, is load up, again, this script right here, the final challenge load, which is the same thing I have here inside of our solution, these 3, and execute it. So what this will do is insert 20 rows, spanned across those 3 years. And what should happen, since we're inserting it through the view, is SQL should put it into the right member table. So we're going to execute that. It's done. And now if we look at each table individually, we should have all that data spread out across their own member tables. Awesome. And now if we just run a query against the whole view, we will get that. There it is. We're getting all the data brought back to us. And now if we run it with a where clause, we can hit execute, and we'll only bring back that data. On top of that, if we look at the execution plan, check it out. It only hit that table. That is super efficient and super cool. Where if we did this before, without a where clause, you'll see in the execution plan, it hit all 3 tables. So I thought that was a fun final challenge task and also extremely useful, because if you do have a table that you have a lot of broken up archive tables, maybe by month or by year, then partition views are a great way to bring them all together, and also a great way to put data in, as you just saw, because SQL will figure out where it needs to go. And that was it. That was the final challenge task. You're watching the Solution Nugget, so that about wraps it up for this virtual Nugget Lab. In the CBT Nugget, we walk through the lab manual for the 70-464 virtual Nugget Lab. I hope that you had fun with this virtual lab. I hope that it challenged you, and I hope that this has been informative for you, and I would like to thank you for viewing.